Good morning, dear students. Now today we'll start the third part of this chapter, motion. Okay. Now in previous lecture we have already learned about the distance and displacement. What is distance? What is displacement? Okay. Then we have already seen the major differences between the distance and displacement. Now today we will continue the topic displacement with the help of some questions. Okay, so we can understand the concept of displacement very clearly. So the question is, okay, the question is, if an object starts its journey from point A and travel in a circular path and end its journey on point A also. Okay, so the starting point and the end point is similar. By this question, we can, by this diagram, we can understand that if any object starts its journey from point A, travel in a circular path around the circumference of the circle and end its journey at point A, the question is calculate the displacement by an object during this journey. Okay, calculate the displacement by an object during this journey. Okay, now as we know that displacement is the distance between the initial point and final point. Okay, so we calculate the displacement. First we will write the formula of displacement. Displacement is equal to the distance between final point minus initial point. Okay, so what is the final point? Final point is A. Okay, if an object starts its journey from A and end its journey at A, so what is final point? Final point is A. What is initial point? Initial point is A. So A minus A would be 0. So the displacement, the answer of this question is 0. As we have already mentioned in the differential, displacement can be 0 or positive. Displacement can be 0 or positive. Displacement 0 भी हो सकता है and positive भी हो सकता है. ठीक है? So this is the example even displacement is 0. So my main aim to give this type of question to understand that or to explain the concept of displacement, that when an object starts its journey from a point and end its journey on a singular point, then its displacement would be 0 in a circular path. Okay, if the initial point and the final point is similar, the displacement would be 0. The displacement would be 0. You can write the important point in your notebook. For a circular path, the displacement of object would be 0. This is the very important question. Okay, this is the very important question. For a circular path, since the initial point and the final point is same, therefore we can say the displacement of object would be 0. You can write down the displacement of an object for a circular path would be 0. Clear? Then the next question is, if I write a question like this, point A, an object starts journey from A to B to C, D and E. For example, this is point B, this is C, this is D and this is E. A, B, C, D, E. If object starts its journey from A to B, B to C, C to D and D to E, okay, and the distance between A to E Okay, 6 meter. The question is calculate the displacement. Calculate the displacement. Okay, with the help of this diagram. I am giving you 1 minute. Okay, see the question carefully, pause the video and get the answer. Okay, so I hope you have got the correct answer of this question. See, an object starts its journey from A to B, B to C, and C to D, and D to E. Okay, I have to calculate the displacement. First, simply write down the formula of displacement. Displacement is equal to the distance between final point minus initial point. Final point minus initial point. Okay, now if I have to calculate the distance, then I will calculate, for example, A to B is 4 meter, 2 meter, 3 meter, 4 meter and 5 meter. Okay, if I have to calculate, one more question, calculate distance also. Okay, calculate distance also. So A to B 2 plus 3 plus 4 plus 5. So 2 plus 3 plus 4 plus 5 meters. So 2 plus 3 is 5 plus 4, 9 plus 5, 14 meters. The distance would be 14 meters. But I have to calculate displacement. Okay. The question is between A to B. Now, as I don't want this distances because we don't have to calculate distance. Okay, I have to calculate only displacement. Now, from A to E, we have to calculate displacement by an object. As we know that displacement is the final point minus initial point. Now, we know that at initial point, the value of the distance would be 0. Okay, and from A to E, it is 6 meter. Clear? So final point is E minus initial point is A. From A to E, the distance is 6 meter minus 0. The answer is 6 meter. Displacement is 6 meter. Or we can simply say displacement. What is displacement? The distance between initial point and final point. Initial point and final point between the distance is 6 meter. So the displacement would be 6 meter. But the distance, okay, from A to B to, for example, A to B to, okay, 3, 4, 5, I have to calculate the full value for the distance. But as I have to calculate only displacement, I will calculate the distance between initial point and final point. Now, the main aim to give this type of question is, I have to explain you that, or I want to explain you that displacement does not depend upon the path followed. Displacement does not depend upon the path followed. Displacement को इससे कोई लेना देना नहीं है कि कौन से pathway से आप जा रहे हो. Clear? Displacement does not depend upon the path followed, whether the path is zigzag, okay, or straight. The displacement does not depend upon the path followed. Displacement only depend upon the distance between initial point and final point. Displacement को इससे कोई लेना देना नहीं है कि आप कैसे पहुंच रहे हो. Clear है? Displacement is only related with the distance between initial point and final point. So in this question, the displacement would be 6 meter. The displacement would be 6 meter. Okay. Okay, one more thing you have to add in your notebook. Two more points in the distinguish between the distance and displacement, which I have taught you in the last lecture. The difference between distance and displacement. The distance, you can add these 2 points also, distance and displacement. Okay, so distance is denoted by capital D. Okay, distance is denoted by D and displacement is denoted by S. Okay, distance is denoted by D, displacement is denoted by S. One more point, distance is equal to speed into time. Okay, distance is equal to speed into time. Distance is equal to speed into time. And displacement. What is displacement? Displacement is equal to velocity into time. Now what is velocity? You will understand later. Now the formula you have to learn. The distance is equal to speed into time and the displacement is equal to velocity into time. Clear? Now the next term is motion. The type of motion is first is uniform motion. Okay, uniform. I think this is sixth concept or sixth quantity we are studying, that is uniform motion. Now what is uniform motion? First we will write the definition of uniform motion, then we will understand it. What is uniform motion? If an object cover, okay, if an object cover equal distance in equal interval of time, then that motion is known as uniform motion. If a moving object, if any object is moving, okay, if any object is moving, so we can say if any moving object covers equal distance in equal interval of time, then that type of motion is known as uniform motion. Okay, I write the motion, it is the motion in which a moving object covers equal distance in equal interval of time. Okay, uniform motion, it is the motion in which a moving object covers equal distance in equal interval of time. For example, time in second and distance in meter. Okay. For example, in first second the object is moving 10 meter. In second the object is moving 20 meter. In third second the object is moving 30 meter. In fourth second the object is moving 40 meter. And in fifth second the object is moving 50 meter. Okay. So in first second, if the object covers a distance of 10 meter, then in second, for example, the object is covered the distance 20 meter. In third second, object is covered the distance 30 meter. In fourth second, object is covered the distance 40 meter. And in fifth second, object is covered the distance 50 meter. If we will make the graph of this table, then we will get the graph like this. Distance versus time in second and distance in meter. Okay, this is origin, x-axis, y-axis. So time, first second, third second, third second, fourth and fifth. And in first second the object is covered a distance of 10 meter. In second object is covered a distance of 20 meter. In third second object covers a distance of 30, fourth 40, and in fifth second object covers a distance of 50 meter. Okay. Now, first second 10 meter, second 20 meter, third second 30 meter, fourth second 40 meter, straight line graph. Clear? So again, if object cover the distance of 10 meter in first second, 20 meter in second second. See, if you are observing carefully, then you can see the difference between these two is 10. Difference between these two is 10. Difference between these two is 10, and the difference between 40 and 50 is also 10. 10 meter difference. Okay, 10 meter difference in each second. Okay, first to second, the difference is 1 second. Second to third, the difference is 1 second. Third to fourth, the difference is 1 second, and fourth to fifth, the difference is 1 second. So what is the conclusion we can write here? The conclusion is in each second, object covers equal distance. In each second, object covers equal distance, 10 meter. So this type of motion is known as uniform motion. And in uniform motion, always you will get a straight line graph. Okay? In uniform motion, you will always get a straight line graph. Clear? So this is known as uniform motion. Clear? So the next is non-uniform motion. Okay? The seventh concept is non-uniform motion. Okay, non-uniform motion. So non-uniform motion, it is the motion in which a moving object, okay, यहाँ पे moving object does not या do not covers equal distance in equal interval of time. Okay, uniform motion. In uniform motion, the moving object covers equal distance in equal interval of time. But in this, it is the motion in non-uniform motion is the motion in which moving object does not cover equal distance in equal interval of time. Or you can write the motion in which object covers unequal distance in equal interval of time. If object covers unequal distance in equal interval of time, then that motion is known as non-uniform motion. For example, we can understand clearly with this table. For example, in first second, object covers 10 meters. In second, for example, object covers a distance of 15 meters. For example, in third second, object covers a distance of 18 meters. For example, in fourth second, object covers a distance of 12 meters. For example, in fifth second, object covers a distance of 9 meters. Okay, so you can see time is equal, time interval is equal, but the distance covered by an object is unequal. First second 10 meter, second second 15 meter, third second 18 meter, fourth second the object cover only 12 meter, and in fifth second object cover 9 meter. So you can see the difference between the distances is 5. Here the difference is 3. Here the difference is 6, and here the difference is 3. Okay, so you can see object covers unequal distance in equal interval of time. When object covers unequal distance in equal interval of time, then that motion is known as non-uniform motion. And if you plot the graph of this reading, okay, distance versus time, then this is the origin. If you plot the graph of this table, then you will not get a straight line, you will get a line like this. Okay, this is known as non-uniform motion. Or you will get a graph not in a straight line, you will get a curved graph. Okay, so this is known as non-uniform motion. Uniform motion, always it is fixed that the graph would be straight line graph, but in non-uniform motion, the graph would not be straight, it can be curved. Okay, so this is the non-uniform motion. Clear? Now the next concept we are going to study the speed. Okay, I am giving you 1 minute time. If you want to write, you can write. Okay. Next concept is speed. Concept number 8. So speed is the distance covered by an object in a given period of time. Speed is the distance covered by an object in a given period of time. The formula of speed we can write: speed is equal to distance upon time. See, this formula you don't have to by heart. Okay, this formula you don't have to by heart, because in the distinguished point we have already mentioned that distance is equal to speed into time. This formula we have already seen in the distinguished point of speed and distance and displacement. In the distinguished point of distance and displacement, we have already seen this point. Distance is equal to speed into time. So by this formula, we can generate the formula of speed. Since distance is equal to speed into time, therefore, what is the speed? Speed is equal to distance upon time is a multiplication, so this would be in division. Okay, so always don't by heart the formula, just understand the formula. Okay, distance, since distance is equal to speed into time, then we can write speed is equal to distance upon time. Speed is equal to distance upon time. If anybody asks you what is the definition of speed, so you can write speed is the distance covered by an object in a given period of time. Distance upon time. For example, in day-to-day life we are saying that the speed of car is, for example, the speed of my car is 60 km per hour. 60 km per hour. So kilometer is the distance and hour is the time. For example, I write 60 km per hour. So this kilometer and hour, kilometer is the distance and hour is the time. So speed is equal to distance upon time. Speed is equal to distance upon time. Okay, we'll see some numerical related to the concept speed. Okay, so the question is, calculate the distance covered by an object. Okay, calculate the distance covered by an object moving with a speed of 40 km per hour or 40 km, moving with the speed of 40 km in 2 hours. Okay. Now calculate the distance covered by an object moving with the speed of 40 km in 2 hours. If any object is moving with the speed of 40 kilometers and the time taken is 2 hours, then what is the distance covered by an object? So we already know that since speed is equal to distance upon time. Okay, speed is equal to distance upon time. Now, what is the distance given? Distance is not given. Okay. Now, speed is given 40 kilometers. Speed is given 40 kilometers. Distance we don't know, so this will remain as it is, and the time is 2 hours. Time is 2 hours. Okay. So, therefore, 40 into this 2 is in division, so it will be in multiplication, and this is the distance. Okay. So the distance is equal to 40 into 2, that is 80 kilometer. Okay, 80 kilometer. If an object moving with the speed of 40 kilometer per hour, then what is the distance covered by an object in 2 hours? So speed is equal to distance upon time. Speed is given 40 kilometer per hour. Speed is given 40 kilometer per hour. Okay, speed is always in the unit of kilometer per hour. Distance is not given and the time is 2 hours. Okay, so 40 into 2 is 80 kilometer. The distance is 80 kilometer. Okay. So I hope you have understood the concept of speed. Now, in next lecture, we will continue with the numericals of the speed and the next concept. So that was all for today's lecture. Thank you.